Hello and welcome to m253, Calculus 3 here at Cañada College. My name is Lapuz. In this video, we'll take a look at this problem from section 2.6. And this is asking us to consider this equation of a surface of revolution formed by, or to find the equation of the surface of revolution formed by revolving this profile curve about the x-axis. So if we take a look at this profile curve and look at its profile, we will see just a simple curve on the xz plane, because those are the variables, and I'll take the z as the dependent variable, the vertical axis. And then the ln function looks like this. The 4ln function would be like the ln function that's been stretched out. So let's draw that with this color. So that is your profile curve. Now let's put that curve on the XYZ space. So this curve is really, if you look at the profile, it actually exists on the XZ plane. So if we take a look at the XZ plane here, your curve will exist in there somewhere, and it would look something like this. It would be, it would have a negative z-axis asymptote, and it will pass through here when x is equal to 1. And it would go down in asymptote, and then it would grow in a logarithmic way this way. So that is your your curve. And now we want to rotate this curve about the x-axis. Okay, so let's redraw that. Your x, your y, and your z, and the curve looks like this with an asymptote here. And we'll rotate it. So as we rotate it around this axis, what's going to happen is that I'm going to get a mirror image around the axis of rotation, and I would be forming circles. So let's draw the circle parts like this and like this. Okay, so that became a lot harder to view now. Maybe I think I might need to make my circles a little bit wider here. So just because it's along the x or along the y. So that's how generally it would look like. Kind of like a really flat looking wine glass or something. Not quite sure how to describe this. So if we make a cross-sectional cut, let's say parallel to the YZ plane, and we draw a plane parallel to the YZ plane, a cross-sectional cut, depending on where you are, if you're bigger than 1 or less than 1, your cross-sectional cut would look like a circle. That is to say, if we were to draw just the YZ axis now, the circle that we're seeing here can be seen projected down to the YZ plane as that circle. So that circle has an equation R, or y squared plus z squared, because those are the two variables. Y squared plus z squared is equal to r squared. And what is r? Well, r is probably something that we're going to need to find. R would be this radial distance here. So what is that radial distance? From my particular cut, that radial distance would be this distance that goes from the axis of rotation to this edge of that curve. We'll draw that here again. It would be from the axis of rotation to the edge of that curve. Or let's draw it here. It would be from the axis of rotation to the edge of that curve. So what is this? This is actually a z value that's dependent on a function of x. So that z value that's dependent on the function of x is actually this ln, 4 times ln x. So the radial distance that we're following along here this is r, so this is actually r. So r is actually z, which is actually 4 ln x. All right, so we'll just take this equation here and replace it appropriately with the variable or the expression. We have y squared plus z squared is equal to r squared. So that's 4 ln of x quantity squared. And that should be your result. I just want to take a quick look at the whole rotation business that's happening. And I have a graph. In CalcPlot 3D, you could do rotations, but they only rotate when your graph is on the XY axis. So we could pretend that this is on the XZ axis by just looking at it like this. So this is the profile that we're seeing. Imagine again, this is the X and Z instead of X and Y, but this is the graph that we're looking at. It's shaded in because this particular program wants a volume, but let's ignore the shading and just look at this. Now, we switched it around to make it look like this to pretend that this is, again, X and Z. So this is how the graph would look like. And this, oops. And then let's actually see it being rotated. So we can do the rotation, and we see that we get the two pieces of the graph that's being rotated. So I let my x value go from 0 to 4. And we can make that go further out, and then you'll see that it actually starts following that. The shape here is the logarithmic shape. Actually, if you look at it this way, the edges that we're seeing here is the logarithmic shape. In fact, you can see it back to this again, and then that being rotated looks like this. All right, so this is the rotation portion. Now in CalcPlot 3D, what I actually did was I took that equation, y squared plus z squared is equal to 4 ln x quantity squared, and I just want to make sure that I didn't have any bad values for x, so my x was started at 0.01. And the default is usually 16, but when you have 16 here, the resolution isn't very good, so I have it at 32. And so now we can kind of view what's happening here as a surface and not exactly as a solid. And this is how it would look like. All right. So yeah, that's it. And I hope that these models help, and it's kind of flashback to your studying the volumes of revolution and then trying to see what that equation will end up looking like. And it's all about circles. Okay, I hope that helps. Good luck.